Hi, this is Jessalyn, and this video is transformations of congruent figures. We know what congruent figures are. Congruent figures are the same size and also the same shape, so exactly the same. And we want to know how the congruent figure has transformed. We know this right here, this one, the black one, is our original figure, because when we write the transformated figure, we write the little apostrophes with it. And so triangle, let's just say CUL, and then triangle C prime, U prime, L prime. And so that is the transformated triangle. We want to know what happened to it. So the easiest way to do this is to actually pick a point. I'm going to pick from the original. So C's located at 1, 1, 2, 3, 4, 1, 4. And then C prime is located at -1, 4. And you can kind of see what happened to it. We can see that the X became negative. Well, if you know all your rules of translating rules of, we can say, well, to me, that could have translated 2 to the left, right? Because 1 minus 2 is -1. But if we go to our Y's, 4 minus 2 would be 2, but we have a 4 and a 4. So we know it's not translated. We can also see in the picture that it's not translated. And then if you know your rotation rules, like if it's rotated 180 degrees, XY becomes YX, and then rotated 90 degrees and 270, you need to know all those rules. If you don't, please go and watch the rotations video. Also, for our reflections, you need to know reflections video. If it's reflected over the y-axis, the x changes. If it's reflected over the x-axis, the y changes. So here, if we notice, it's the x that changes. It becomes opposite. So we know that follows the rule about being reflected over the y-axis. And we can determine if that's true with all of it. If we look at it, is it reflected over the y-axis? 1 away from the y, 1 away from the y, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 away from the y. U is 5 away from the y over here. And if we checked all their points, we would notice that the x coordinates became opposite. And so that tells us that it's reflected over the y-axis. But this is a good strategy to determine what the transformation is. Pick a point and then see how you can get there. And then you can check it with all the other points once you determine that one point. Okay. Let's see if we have another. We do have another down here. Okay, so let me put my brush back on. So again, I'm going to do the exact same thing. This is our original figure, the black. I'm going to pick the point V. Our V point is at 1, 1, right? And our V prime is at -1, -1. So in this case, is that our V point? Yes. So in this case, it looks like our V changed to its opposite as well as our Y changed. Let's just pick another point to see if that works. Let's do R. Because if our X changed and our Y changed, that means it's reflected over both axes, right? If it just became opposite. But I just want to check that with another point. So R is 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. And then R prime is over 1, 2, 3, 4. So -4, and then down 1, 2, 3, 4, 5. -5, it works. So we know since both of the x coordinate became opposite and the y coordinate became opposite, it's reflected over the x-axis and also the y-axis. And that's how you get the transformation. So it's reflected over both axes, and we can do that by doing this. So if I reflect this over the y-axis, it doesn't matter the order. Let's say if I reflect it over the y-axis, V will be here, and then it's reflected over the x-axis, right? If I reflected it over the x-axis first, V would be here, and then it's reflected over the y-axis. So it doesn't matter the order of reflection. We just know it's being reflected over both the x-axis and the y-axis. Thank you for watching.